In this lesson, you will begin to learn how to solve quadratics with the quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. This method of solving works best for problems in standard form, actually for all equations. This is a great method for all equations in standard form because it always works. If the equation is in vertex form, it actually cannot be used. In today's lesson, you will only learn how to find the discriminant and describe the number and type of solutions. You will not actually solve any quadratic equations. We will just determine how many and what type of solutions. So in order to do that, we actually just need this chart. And we'll be evaluating what's called the discriminant, the b squared minus 4ac. So notice where that is at in the quadratic formula. It's underneath the radical for that b squared minus 4ac. So if the value of our discriminant is positive, meaning it's greater than 0, if that is true, then the number of solutions, we will actually have 2, and the type are real solutions, meaning that our graph, if we were to graph it, will have 1, 2 x-intercepts. If our discriminant is positive, we have 2 real solutions, meaning it crosses the x-axis at 2 places. If the value of our discriminant equals 0, we actually will have 1 real solution. Be very careful. Students confuse this, sometimes saying the discriminant 0 is 0 solutions, and that is not true. If the discriminant equals 0, we actually have 1 crossing here or any place on the x-axis. And then finally, if your discriminant equals a negative number, meaning less than 0, we can actually call those as 2 non-real, and yes, there's such a thing. It's actually called the imaginary solutions. And so that means that it will not have any x-intercepts along this x-axis. They will not cross. So notice our graphs can open up or open down. So even with 2 x-intercepts, you could have a graph opening up and crossing at 2 places. And the same for 1 x-intercept. It could open down and cross at 1 x-intercept. Or even a graph with no real solutions, it could open down and still not cross the x-axis. So it's not related to opening up or opening down. It's just the value of the discriminant. If it's positive, negative, or 0, it determines how many times it crosses the x-axis. Let's look at some examples. We're going to find the discriminant of each quadratic equation and then describe the number and type of solutions. Well, first thing first, in order to do this, we need our equations in standard form. In order to get it in standard form, it does need to be set equal to 0 and our a, b, and c terms in order. So let's first get that done by adding 4x. I typically have 2 tips for students when finding standard form. Either 1, do the least amount possible of work. So if you only have 1 term to move, that's a lot less work than moving 2 terms. And then even more important is trying to keep your a positive. So we were able to do that both here with this problem. Just moving this 1 term was the least amount of work, and our a was already positive. By leaving that on that side of the equation, it kept it positive for our next step. So these cancel, getting 0 equals. We're going to put that ax squared first, and then our bx term, and then finally our c. And because none of those were like terms, we're going to just list them in that order: ax squared, bx, and then c. Let's name those a, b, and c's now that we're in standard form. A is a 1 because there's not a number in front of the x. We know it's an understood 1. Feel free to write that in if you need. B is a 4, and then finally C is a 1. Well, we'll need to find the value of the discriminant using our formula. B squared minus 4 times A times c. I always recommend using parentheses when you're substituting, especially when you're squaring a number. So let's look at our note here to the side. You must use parentheses when you're squaring a negative. We don't have that currently, but it will show up. So if we have negative 4 squared without parentheses, it's actually taking 4 times 4 and then multiplying it by a negative 1. That's order of operations, squaring, and then you multiply. But if it's negative 4 squared with parentheses, you're telling it you want to multiply negative 4 times negative 4, and that is a different solution. So always be careful when you're squaring negative numbers to put them in parentheses. So it may be best just to always get in that habit to use parentheses. So let's go to the calculator. I recommend just typing this exactly as you see it. So 4 squared minus 4 times 1 times 1. And that was our b squared minus 4ac. For our discriminant, we get a value of 12. So because our discriminant equals 12, let's refer back up to our chart. Because that is a positive number, we're going to have two real solutions. We don't know what those solutions are currently. We'll learn that in a later lesson how to find those solutions. But this discriminant being a positive value does tell us that we will have two real solutions. Let's look at example number 2. Well, this almost looks like standard form. However, they're a little jumbled up, so don't let it trick you. Just because it's set equal to 0 doesn't mean that we are in standard form. Our ax squared needs to be listed first, and then our bx term, and then finally our c. So we have 2x squared minus 6x plus 15. Feel free to move that equal 0 to either side that you're comfortable with, but as long as your a, b, and c terms are in the correct order, we can now name them. A is 2, b is negative 6, paying attention to that sign, and then c is 15. Be very careful to make sure it is in standard form before you name that a, b, and c. We would not have wanted to call 15 the a, 2 the b, and negative 6 the c, because that would have caused us to get the incorrect value for our discriminant. Let's use our formula, b squared minus 4ac. So b is negative 6, and we'll square that, minus 4 times a, which was 2, times c, which is 15. So just plugging those in exactly where the formula tells you to for b squared minus 4ac. We could use order of operations, but I'm going to use my calculator because it will not tell me wrong as long as I type it in correctly. B squared minus 4 times a times c. One error I will say that I find students doing is here when it's a minus 4, you have to use the minus key and not the negative. We know they're the same, a minus and a negative. However, the calculator does not. You have to tell it what sign to use. So a negative 4 and a minus 4, the calculator needs to know the difference. Here we have negative 84 as our value of our discriminant, negative 84. So in order to tell if that has how many solutions it has, let's again refer back up to our chart. Because the value of our discriminant is negative, we know that we will find two non-real solutions, meaning this does not even cross the x-axis at all. Two non-real. And that was because that was a negative number. One final example, again, starting first with standard form. Well, we got a lot going on here. The first side of the equation has the 3 terms, and it looks pretty close to standard form. We have an x squared, an x, and then just a constant term. But we know it's not in standard form because we have these other 2 terms. We need it equals 0. Again, remember my tips. Do as little as work possible. So I'm going to move 2 terms instead of all 3 of these. And try to keep your A term positive. So because it's already positive, I definitely don't want to move that around. So I'm going to move these two terms to the left in order to get standard form. So we'll start with subtracting 4x, and I'm going to line it up with the other x term. They are like terms, so we will be able to combine those. Then we'll also add 3, again lining it up with its like terms. This right-hand side, they truly cancel, getting our equals 0, which is what we need for standard form. So let's write the left-hand side. We have x squared, negative 2x and negative 4x gives us negative 6x, and then 6 and 3, when we add those, give us 9. So that is our equation now in standard form. We're now able to name our A, which is 1, B is a negative 6, and our C is a 9. Always being careful if your terms are negative that you include that when you name A, B, and C. So let's plug them into the discriminant, which is negative 6 squared minus 4 times 1 times 9, using that B squared minus 4AC. Let's use that calculator to help us solve order of operations correctly. Negative 6 squared minus 4 times 1 times 9. Which we didn't technically have to have parentheses on the last one. It would have known to multiply. But might as well write it exactly as you have it on your paper so that you know that you've typed it in correctly. Our value of our discriminant equals 0. Be very cautious of this. A lot of students want to say that's no real solutions. That is not true. Go back up to your chart. If the value of your discriminant equals 0, that means it has one real solution. The graph will cross one spot on the x-axis. So here we have one real solution. In our next lesson, we will actually learn how to solve for the solutions, but this is just the beginning of the quadratic formula with the discriminant.